What's up? I'm Vin, and today I want to go through the multiple choice of the August 2022 Geometry Regents. So let's get started. So first up here, we have triangle ABC reflected over line L to create this triangle DEF. And we're given the measure of a few angles. So we're told the measure of angle A is 40 degrees. So I'm just going to label this 40. But just know when this is reflected, this angle over here is also going to be 40 degrees because the way a reflection works is that the reflection line itself is the perpendicular bisector of this point A and its image, which we could call this A prime if it wasn't labeled, but they went ahead and named it with vertex D here. But just know that's mapping A to A prime, but in this case we're calling it D. So when you reflect one triangle over a line, it preserves distance and it preserves angles. It's going to keep this triangle congruent to the original. So then here we're told the measure of angle B is 95 degrees. So angle B would correspond to angle E in this triangle over here. So then what we also need to know is that in a triangle there's 180 degrees. So if we add 95 plus 40, that's going to give us 135. And now if we do 180 minus 135, this is going to give us, we're going to have 45. So this tells us the measure of angle C is 45 degrees, as is the measure of angle F. So now when they're asking us, what is the measure of angle F? 45 degrees, choice 2 is our answer. So question 2, we have triangle ABC, X is on side AB and Y is on side CB. And we want to know which information is sufficient to prove that these two triangles are similar. So we have BXY, which is this triangle here. So B to X to Y. So we want to see which information do we need to prove that this triangle in red is similar to this triangle here in green. Now, with these questions, what jumps out at me when we have similar triangles that share a vertex like this, where one triangle is inside the other triangle, is they share a common vertex, but we would need another pair of angles to be the same. So let's say this angle here, we have angle ACB and angle XYB like this. Now, the only way that these angles would be the same would be if these two lines were parallel. Because what I'm imagining here is this diagram here, and I'll draw it in the more standard form. When you have parallel lines cut by a transversal like this, the corresponding angles formed are congruent, provided once again that these lines are parallel. So that's the idea, to give us the second pair of congruent angles. And then we could also show that these angles are congruent and making these triangles here definitely similar. But we need to show that XY is parallel to side AC. So question 3, we have quadrilateral math is congruent to quadrilateral, and we have this letter arrangement here. So what I would do, it helps to sometimes just draw these out. Now, I'm not the greatest artist in the world, but there's our first quadrilateral, and I'll try to draw the second one to be like exactly the same as the other. But one thing you have to do, notice I started with M in the lower left corner, so I have to start with W in the lower left corner. And if I went from M to A to T to H, then I have to go from W to X to Y to Z. So the letters have to be in corresponding order when they tell you a statement involving congruence. So here, is MA congruent to XZ? Well, not necessarily. Let's say all the sides here were different. MA would have to be the same as WX or XW. So this one is not always true. We need something that is always true. So angle H is in the lower right corner, would have to be congruent to angle Z, not necessarily angle W. So this one is out. This quadrilateral, we have quadrilateral WXYZ could be mapped onto quadrilateral math using a sequence of rigid motions. This is definitely the one, because when you have two congruent figures, we can move this one on top of this one where all the sides and angles fit perfectly with no overlap. So I'll just humor the last one, but it's not going to be it. So quadrilateral math and this quadrilateral are the same shape, but not necessarily the same size. This one's out. This is more about similar, like, we could talk about similarity in this case. So the angles are the same, but they're not necessarily the same size, but congruent means the sides have to be the same as well. So definitely choice 3. So question 4, we have diagonals are perpendicular, but they're not congruent. Which quadrilateral could we be talking about? Now, if you just know that this is a rhombus, then awesome. But let's say you forget the definition. What you could do is just draw two perpendicular lines that are not necessarily the same size. And then what you do is you just, to the best of your artistic ability, you connect these points like this, and notice what it's making a rhombus. Okay, definitely not a square, not a rectangle, because these are not right angles. And an isosceles trapezoid, we just drew out a rhombus here. So definitely choice 2. Question 5, which regular polygon, which means polygon where all sides and angles are the same, has a minimum rotation of 36 degrees about its center, and that will carry the polygon onto itself? So what I imagine for these questions is we could spin a total of 360 degrees, but we don't spin 360. We could spin X number of times, and each time we're spinning 36 degrees, and that's going to keep mapping the polygon onto itself. So what this gives us is we're going to have 36 degrees times X equals 360 degrees. And the degree symbol doesn't matter here because we're in the multiple choice. Like, they're not going to grade you on your notation here. But what this tells us is that X is equal to 10. So we need a 10-sided figure, which is going to be a decagon. Now, just so that you definitely get the concept of this, like, you have a whole bunch of points here. So we have 10 points, and I'll just draw this carefully. But the idea being is that if we have 10 sides, then we're going to have 10 central angles that will connect to each of these vertices going around. So if you think about it, 360 divided by 10 tells you each of those central angles is going to be 36, which means if we keep rotating this 36 degrees, we're going to have a figure that's looking exactly like what we have here with no overlap. If we spin by some multiple that's not going to give us 36, then maybe one of the vertices would wind up in the middle here, and we would have a different looking shape from what we started with. So definitely choice 4. Question 6, we have triangle RST is the image of ABC after a dilation centered at point P. So one thing to be mindful of here is that this is the pre-image. We're starting with this triangle, and then we're doing a dilation with this center to land here. So one thing I like to do for questions like this is I count the rise over run. And I pick a corresponding point in both triangles, like let's say point A, and that would correspond to point R. So when we're looking at triangle ABC, how do I get from A to the center? I have to go up 1, 2, 3, and to the right 1, 2, 3. So my rise over run is we're going up 3 over 3. But now if we look at triangle RST, now we look at this point R, the image of A, and here we would have to go up 1 over 1. So the rise over run is just going up 1 over 1, and this is going to help us find the scale factor. Notice if I'm going up 3 over 3 and then later I'm going up 1 over 1, I'm traveling a third of the distance. So that tells us we have a scale factor of 1/3. And now we could pick another point here, like let's say B. To get from B to the center, we're going up 1, 2, 3, 4, 5, 6, and going over 1, 2, 3. So you see how we're going up 6 over 3, but now if I look at the corresponding point S, I'm going up 1, 2 over 1. So if you compare this, notice going up 6 versus up 2, 2 is a third of 6, and 1 is 1/3 of 3. So the scale factor of 1/3 is looking good. So 6 is going to match up with choice 1. Question 7, we have this nice diagram here, and we have to know SOHCAHTOA. This is a helpful mnemonic to tell us which trig function we should use. So we want to find the measure of angle A over here. But now I just think about which sides do we know? Well, 13 is opposite of angle A. So we know the opposite side, and the adjacent right now is not known, and we know the hypotenuse. So when you know the opposite side and the hypotenuse, this tells you that you're going to go with sine, because in general, know that sine theta is the ratio of the side opposite over the hypotenuse. So now we just combine all this, and we have sine of angle A is equal to the ratio of the side opposite A, which is 13, over the hypotenuse, which is 16. So then to solve for the measure of angle A, we have to do the opposite of sine, which is sine inverse. So we have sine inverse of 13 over 16, and the rest is calculator work. So now to work this out, notice we are in degree mode, and we have to get sine inverse. So that's second sine, and then we have 13 over 16. And for this question here, we were rounding to the nearest degree. So this is going to work out to 54 degrees. Question 8, we have the Pyramid of Memphis in Tennessee, and it stands 107 yards tall. So the height is 107 yards, and we have a square base. So what I like to draw out with these, if this picture doesn't really do it justice, is a square pyramid, and I'll draw this a little bit slanted here, has a square base, and then all of these points here will connect to the top of the pyramid like this. So the pyramid is going to look something like this. If we were able to see through it, it would look something kind of like this. So then the formula for finding the volume is 1/3 capital B times H, where this is the area of the base. But notice this is a square pyramid, so the area of the base is equal to the side length squared. If S doesn't do it justice, I could just go ahead and use X, where X represents, one side over here like this. And they told us the side is 197 yards long. So we could say here X is 197 yards. So then to find the volume of this thing to the nearest cubic yard, so we're going to round to the nearest whole number, the volume is going to be 1/3. B is X squared, so we're going to have 197 yards, and we're squaring that, and then we're going to multiply that by the height, which is 107 yards. And just know at the end, when you multiply yards times yards times yards, you're going to get yards to the third or cubic yards. So we can just type this out. We have 1/3, so we have, I'll just put that in parentheses, 1/3, and then we have 197 squared. So I'm going to write times 197 squared, and then the height was 107. So we just punch that in. We have 107, and this is going to work out to 1,384,188 if we round to the nearest whole number, and we have cubic yards. So just borrowing what we had from the calculator, rounding to the nearest cubic yard, we're going with choice 2. Question 9, we have these 4 vertices graphed, and we want to know which transformation would not. So that's a little bit of a trap there. Make sure you're finding the one that does not work out, but which one is not going to carry the square onto itself. So if we look here, a reflection over the y-axis, this is already standing out as the answer, because if I were to reflect this square over this line, notice that there's only one square length to the left of the line, but here we're going 3 square units to the right. So that means when we flip this point, let's say this one, we would go 1, 2, 3, and then 1, 2, 3, and you see this point would land not on the original square. So already this is looking like choice 1 is the one that doesn't work. But now if you look at why is choice 2 something that would map the square onto itself, if you look at the x-axis, see how here this point would go down 1, 2, and then it would go down another 2 and map here. So all of these points would work perfectly here, would map onto themselves, because this line on the x-axis essentially folds the square exactly in half. So this one is good. A rotation of 180 degrees about the point 1, 0. Well, one thing to note here is that 1, 0 is smack in the middle. This is the center of the square. So if you spin this square upside down from the center, it's going to be presenting you with the same square. So this one's out. And now if we look at the last one, the line y equals x minus 1, if we were to graph that, notice this is the y-intercept -1, and we go up 1 over 1, and we'll just change colors here. So we're going up 1 over 1 like this. This line would be a diagonal line, and this diagonal line cuts the square exactly in half. So if we fold the square over this dotted line here, or over this solid line in green, this square would fold perfectly in half, landing everything on this side would land perfectly with everything on this side. So that's why choice 4 is out, and it's definitely choice 1. Question 10, we have a scalene triangle XYZ, and this triangle is similar to triangle QRS, and we have the measure of angle X is 90. We want to know which equation is always true. So for this one here, I would draw out both triangles. So I'm going to draw out XYZ, and we know XYZ is a right triangle because angle X is 90 degrees. So this is going to be X over here, and I'm just going to put Y up here and Z over here. So now if I draw another triangle, I'm going to draw it the same shape but a different size. And for this triangle, we're going to call this one QRS. But just know the letters have to be in corresponding order. So X shows up first, Q shows up first. X is by the right angle, so Q is going to be by the right angle. Now the middle letter is Y, and that's up here. So the middle letter R is going to go up here. So then S would have to go here. So now what I'll do is I'll just pick out random values here for this triangle. So let's say this triangle QRS, I'm just going to give this 3, 4, 5. Well, in this triangle XYZ, these triangles are similar, so they don't necessarily have to be the same size. But let's say I just double each side and I make it 6, 8, 10. So now when we go through each of these answer choices, it involves trig functions. So I'm going to use this mnemonic again, SOHCAHTOA, to help us make sure we're setting it up right. So sine of y. Well, sine of y would be opposite of y, which is 8. So for choice 1, we're going to have 8 over 10. So that's opposite of y over the hypotenuse. Is this equal to sine of s? So in this triangle, opposite would be 3 over 5, but this is not true. This is not true because if we divide the top and bottom by 2, we would get 4 over 5, not 3 over 5. So this one's out because this equation is false. Now we have cosine of r. So cosine of r, if we look over here, adjacent to r would be 3 over the hypotenuse 5. And the question is this equal to cosine of z, which would equal 8 over 10 in this red triangle? But same problem as before, these are not equal, so choice 2 is out. And now we have cosine of y. So for choice 3, cosine of y, we're going adjacent to y is 6 over the hypotenuse is 10, and sine of angle q, well, sine of q is 90 degrees, and sine of 90 degrees is equal to 1. So this choice is out. And just by process of elimination, it has to be choice 4. But if I really want to verify here, I would take sine of angle r, which is 4/5, because we're going opposite of r is 4 over hypotenuse 5. Is this equal to cosine of z? And adjacent to z is 8 over the hypotenuse 10. This one is definitely true, so definitely choice 4. So question 11, we have a plane intersects a cylinder perpendicular to its bases. So just know the bases are here. So if the plane is going to be perpendicular to the base, that means the plane has to be coming in going this way. A common mistake for this is students might just draw it going in horizontally like this and think that it's going to cut and make a circle. But since it's going in this way, when the plane, I just imagine it going through like this, hits this cylinder, we could see here that the actual points of contact when we draw this all the way through, if we highlight this in a different color, it's going to hit, let's say, here, 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 and somewhere down there. This is actually going to make a rectangle. So if we draw this carefully here, and I didn't draw that purple one so well, but the idea is that the purple one would look something like this, but you could see that the two-dimensional cross-section that we're looking at a rectangle. So this is definitely choice 1. Question 12, we have two equations, one for line P and one for line Q. And which statement about these lines is true? So for choices 1 and 2, they're saying that a dilation occurred. But one thing we have to know about dilations is that the dilation of a line, so a dilation does not change the slope. So a dilation does not change the slope of a line. So this is a big idea, because when we go through this, notice these lines here, this line has a slope of 1/3, and this line has a slope of 2/3. And for lines to be parallel, that means their slopes have to be equal. So since these lines are not parallel, that means a dilation is out. But choice 3 is the one. Line Q is not the image of line P after a dilation because the lines are not parallel. And once again, it's because their slopes are different. Okay, so that's how we know this is going to be choice 3. Now if we look at choice 4, line Q is not the image because the lines do not pass through the origin. That doesn't matter. You could have parallel lines that don't pass through the origin. So definitely choice 3. So question 13, these type of questions are a little bit tricky, but what I like to find here is I like to find the change in x and I like to find the change in y, because we're talking about going from point S to point C. So we could graph this out, but I prefer to just do these by just analyzing any segment here, not necessarily a segment going at a specific angle. So here are the endpoints of SC, and what I like to look at is the change in x, and I like to look at the change in y. So notice the change in x, to get from -7 to +2, I have to go up 9 units. So -7 plus 9 would bring us here. And the change in y, to go from 3 to -6, I have to go down 9 units. And now the next part of this concept is that point M is on SC in such a way that the ratio of SM to MC is 1 to 2. So that means that point M would be somewhere here, because once again, this piece here, this segment, is going to be half as long as the remaining segment. So what that means is if I put in more points, that we have another point here, and once again, you see how this is just one part, but after M, from M to C, there's 2 parts that are equal to SM like this. So that's a visual concept of what's going on. But now, why I like to find delta x is if I'm going to go forward 1, 2, 3 equal steps to get from S to C, if I do delta x divided by 3, that's going to give us 9 divided by 3, which is equal to 3. And what that tells me is that to find my missing coordinates, I'm just going to keep adding this number. I'm going to keep adding 3 to the x's. So if we did -7 plus 3, that would give us -4. If we do -4 plus another 3, that's going to give us -1. If we do -1 plus 3, you see how that's going to bring us directly to 2. So that's how I know we're counting by the right number. And now we repeat this process for y. So now delta y broken into 3 pieces would be -3. So now we're going to keep subtracting 3. So we have 3 minus 3 is 0. 0 minus 3 is -3, and -3 minus 3 would bring us directly to -6. So what are the coordinates of m? The coordinates of m are -4, 0. So question 14, we have a rectangle here, and we're told the coordinates of this rectangle, and we want to find the area of rectangle wind. So to find the area of this rectangle, we're going to do length times width. So we need to find the length of, let's say, this side, and we're going to find the length of this side over here. So what we're going to do for that, let's say I forget the distance formula. I want to count the rise over run. So notice I have to go down. I'm going down 1, 2. So I'm going down 2 units like this, and I'm going over 1, 2, 3, 4, 5, 6, 7, 8. So I'm going down 2 over 8, and notice this makes a right triangle where the hypotenuse is side dn. So now to find the length of dn, I have dn is equal to, and I'm essentially using the Pythagorean theorem, so I could say dn squared equals 2 squared plus 8 squared, and then I take the square root of both sides, so dn is equal to, and this is going to give us, we have 4 plus 64, so that gives us the square root of 68. And this could break down to square root of 4 times the square root of 17, which is 2 square root of 17. So this is going to come in handy in a moment, but now what I want to do is find the length of the other side. So for this one, I'm going to the right 1 unit. So I'm just going to build a right triangle here, and I'm going up 1, 2, 3, 4. So now we have a right triangle with legs that are side length 1 and 4. So to find the length of this side, we're going to use Pythagorean theorem. So I have ni squared is equal to 1 squared plus 4 squared. So ni squared is equal to 17, which tells us that ni is equal to square root of 17. So now to find the area of the rectangle, area of a rectangle is equal to length times width. So that means the area of our rectangle here, we're just going to multiply the length was 2 square root of 17 times the width is square root of 17. And now we're multiplying matching radicals. So I'm going to have 2 times square root 17 times square root 17 is just 17. So, and we'll make that a little bit neater. So we have 17, and that's going to give us 34, which is choice 4. So question 15, we have a parallelogram here, and we have EB bisects angle ABC. So if EB bisects this angle over here, ABC, that means that these two angles here are going to be the same measure. So that might come in handy a little bit later. And now we're told the measure of angle A is 40 degrees, and we want to know the measure of angle BED over here. So I'll just throw an X here. That's what we want to find. So because this is a parallelogram, opposite angles are the same. So that means this angle over here is also going to be 40 degrees. And consecutive angles of a parallelogram are supplementary. So that means that angle D and angle B, this entire angle, I could find by just doing 180 minus 40, which is 140. So this angle is 140, and that means this angle is 140. But since it's bisected, each piece is going to be 70 degrees like this. So now when I want to find the measure of angle BED over here, I could use the exterior angles theorem and just do, see how we have these two remote interior angles. I could say X is equal to 70 degrees plus 40 degrees. So X is going to be equal to 110 degrees. And that's going to give us choice 3. Now, just know, I could also say here, because this is 70 and this is 40, that I have 110. So that means this angle has to be 70. And if this angle is 70, on a straight line, we have 180. So that's another reason why X is 110. So definitely choice 3. Question 16 is a little bit tricky. We have right triangles ABC and RST. We have the hypotenuse AB equals 4 and the hypotenuse RS equals 16. And now we're told that the two triangles are similar, and we want to talk about this ratio. The 1 to 16 ratio is the ratio of the corresponding blank. So for this question, I would 100% draw this out. So we have triangle ABC, and AB is the hypotenuse. So I'm going to label the longest side AB and put the 4 here, which means C is the vertex where the right angle is. And now in the big triangle, we have triangle RST. That RS is the hypotenuse here. So R goes here, S would go here, and that means vertex T is the location of the right angle. So looking at this, make sure the letters are in corresponding order. See, we go A, B, C, so then we have to go RST in that same orientation as the first triangle. So now here, the hypotenuse of the second triangle is 16 units long. And now this ratio actually represents the ratio of the corresponding areas. And the reason why is the scale factor, to get from this triangle to this triangle, we have a scale factor of 4, because we have to multiply each side by 4 to get from here to here. But let's say I call this side x and this side y. Then this side would be 4x and this one would be 4y. And what we would have is the area of the first triangle is 1/2 base times height. So the base would be x, the height would be y. But watch what happens when we find the area of the second triangle. We're going to have 1/2 the base 4x times the height 4y. And if we take the ratio of these two, if we divide these two, I'm going to do the first triangle, 1/2 xy, that area divided by the area of the second triangle, which we have this 4x 4y. Notice the half cancels out, the x's cancel out, and the y's cancel out. And we're left with 4 times 4 on bottom, so we have 1/16. And there's our ratio, 1/16, from comparing the areas. Question 17, we have a parallelogram. We have diagonal DB, and segment EF is drawn in such a way that this segment bisects DB. So DB is the one being bisected at point M. So that means that these two segments are going to be the same. And what we're actually trying to show here, or look for, is which triangle congruence method would prove, so let's just make this neater, would prove that these two triangles are the same, triangle EMB and triangle FMD. So for this, it really helps to know what the angle side angle postulate looks like, and also what the angle angle side postulate looks like. So what we have here is, if I have two pairs of congruent angles in both triangles and the side between both of these angles is also the same, then we could use the angle side angle postulate to prove these two triangles are congruent. Now the angle angle side postulate, the way this looks is, if we have two congruent triangles, and I'm just drawing random ones here, this is when we have two pairs of congruent angles. So let's say these angles are the same and these angles are the same, and then we're also able to show, or we're given, that we have one pair of congruent sides, but the congruent sides are not between the two angles we have. So I'm essentially looking for this within the diagram. Now here, so far we have one pair of congruent sides, but we have intersecting lines, which means that we have a pair of vertical angles, and vertical angles are congruent. Now since this is a parallelogram, I know that opposite sides are parallel, so I have alternate interior angles. So I look for that Z shape here, so I could show that this angle, and I'm going to put two notches because these already have a single notch, and this angle are the same. So you see, right now I have angle side angle. So that means that angle angle side only is out and the neither answer choice is out. But now we have to look for angle angle side. And to find the angle angle side, we have to be able to argue that these two angles are the same. And we know they're the same because we have, once again, alternate interior angles. EF could act as a transversal. So that means these angles are the same here. So notice I have these two angles with the double and triple notch, and I have a pair of sides congruent that's not between those. So that's how I know angle angle side also applies. So it's both postulates or congruence methods that we could use, and that means the first choice is out. Definitely choice 3. Question 18, we have a diagram of circle O, and we have 4 chords that are drawn in, and we want to know which statement must always be true. Not sometimes, we need it to always be true. So AB is congruent to CD. Well, just looking at this, I don't have the greatest eyesight in the world, but it looks like AB is longer than CD. So I'm going to cross that out because we need the one that's always true. And if I look at the second choice, AD is congruent to BC. And AD does look longer than BC, so I'm not convinced that that one's always true. I mean, I may come back to this if all the answers don't convince me, but I need the one that's most convincing. So angle B is congruent to angle C. Well, angle B looks slightly bigger than angle C, so already I'm not convinced of that one. That one's also not looking good to me, so I hope choice 4 has something good. And angle A is congruent to angle C. Well, here's the part that's actually backed by theory. If we look at angle A, notice that angle A, if we draw it in, intercepts arc BD. So angle A is an inscribed angle and it intercepts this arc. So let's say this arc, I'll just make something up. Let's say that this arc was hypothetically like 60 degrees. Then the inscribed angle is half the measure of that. But notice that angle C is an inscribed angle and it's intercepting the same arc. So that means the measure of angle C is half the measure of BD. So this would also be 30 degrees. So choice 4 is looking good. So question 19, we have to know the equation of a circle. And the equation of a circle, we have x minus h squared plus y minus k squared equals r squared. And this is when you have a center hk, and your radius is r. So now that we have this formula, we have to use completing the square here. So what I like to do with these equations is I start by moving the constants to the other side. So I'm going to add this to both sides, and our new equation is going to be x squared plus y squared minus 12y. I'm going to leave a little space. So I'm leaving a space, and this is equal to 20.25. And what we do when we complete the square is we target the b term. And what we mean by b term is, in general, when you have a quadratic expression, the b term is the coefficient of x. So notice that x squared doesn't have any extra stuff attached. So I'm going to leave the x squared alone. But the y squared minus 12y, the b term, in our case here, our b term is negative 12. So then what we do from here is we take half of the b term and we square it. So we're going to have negative 6, and negative 6 squared is 36. And that's what we're going to add to both sides. I'm going to do plus 36 on both sides. And now what this gives us, it gives us a perfect square trinomial. So now we have x squared plus, and this is going to factor to y minus 6 times y minus 6, or we could call this y minus 6 squared. And when we add these two, we're going to have 56.25. So now one thing to be mindful of is that in the equation, r is being squared. So when I want to identify, we have r squared in this case is equal to 56.25. We take the square root of this, and this is just going to be calculator work, but that would work out to 7.5. So now we're ready to identify our center and our radius. Now, one thing to be mindful of, if it's not obvious, is that x squared, I can write it as x minus 0 squared, but I don't need to. And that just helps me identify our center, that technically I have x minus 0 squared, so h is equal to 0, k is equal to 6. And a little trap here is that make sure that you're flipping the sign. Notice it's x minus h, y minus k, but the center is hk. So whatever you have in front of you like this, you just have to flip the sign. But what we have after this now is we have our r value is equal to 7.5. So now we just have to match this to the answer key, and this is going to be choice 1. So question 20, we have this rectangle. We have lines of symmetry. L is vertical, M is horizontal, but these are lines of symmetry that intersect at point E. And we want to know which sequence of transformations will map triangle ABD onto triangle CBD. So for this one, we just have to go through the answer choices one by one. So if we reflect over line L first, that's the vertical line, and we're starting with this triangle ABD. If we reflect over this line, and then after that we rotate 180 degrees about point E, is that going to send us here? Well, I want to say the point to pay attention to. The point to pay attention to is, I'm going to look at point A. So if point A were to go and reflect over line L, that would put it at B. But now if we were to rotate this, and be mindful, this is the right angle. If we were to rotate this, so now the right angle is over here, we rotated 180 degrees about point E, that would put the right angle at this location. But notice the right angle is at point C. So that's how I know choice 1 is out. If we were to reflect over line L first, so same start, then let's look at point A. So A goes over to point B, so the right angle's here, and then we do a reflection over line M. This one is looking good, because you see it puts the right angle here at point C. So we're flipping this, the right angle is going to B, and then it's going down here. So that one I'm convinced is it, but I just want to verify that the other ones are no good. So if we look, a 180 degree rotation about point B, the problem with this one is that if we were to rotate this triangle and we rotate it about point B 180 degrees, what that would do is it would spin it 180 degrees, but it would wind up all the way over here. It would be like all in this space here. So going into like this section like this. All right, so it would be way off the page. It would miss this space over here. So this one is not going to be the answer choice. So I'm not, once again, choice 3 is sending this triangle way too far out. So that's why choice 3 is no good. And now a reflection over line DB. The problem with that is if we follow the right angle, if we were to reflect the right angle over line DB, that would send it over here and it would look something like this. And you would see that it doesn't fall on triangle CDB. So that's how I know choice 4 is out. Definitely choice 2. Question 21, we have a countertop and it's made of solid oak. It's 3 inches thick and we're told the density. It's 44 pounds per cubic foot. And we have all the measurements here, but we want to find the approximate weight in pounds of this countertop. So what I do for questions like this is I try to section this off in a way that I have 2 rectangles. So let's say I draw this line in like this. So now that we have a rectangle, this is 3 feet, 10 feet. This is going to be 3 feet. And this entire distance here is also 10 feet. But now if this entire distance over here was 12 feet, so this entire thing here was 12, then that means that this piece is 3 feet shorter than the entire thing is going to be 9 feet. So that means this piece is 9. So that means this piece is 9 feet, which means this piece here is also going to be 9 feet. And another thing to look out for, since the density is, I'll write the density is 44 pounds per cubic foot, notice that density is measured just in terms of feet, and in this case cubic feet. So the 3 inches, the thickness, I'm going to express in feet, and this is 1/4 of a foot. If you have to, you could convert that on the side. You could do 3 inches times 1 foot divided by 12 inches, and the inches cancel, and then this is 1/4 of a foot. Or if you could just do that quickly in your head, that's fine too. So now what I focus on is we have 2 rectangular prisms. We have this first part here and the second part. So the full volume of this thing, what we could do is we could add both of these together. So the full volume we're going to get by doing, we have in this rectangle, it's 10 feet by 3 feet by 3 inches, which is 1/4 of a foot. And then we're going to add that to the volume of the second part, which is going to be 9 feet. And let's just write that nice. So we have 9 feet times 3 feet times 3 inches, which is 1/4 of a foot. And now this works out to, we have 30 times 1/4. So I'm going to write this as 30 over 4. And we have cubic feet plus, and then this one is going to be 27 over 4 cubic feet. Now we could use a calculator for this, but the fact that this is 44 is going to make this simplify nice. So another idea is that density is equal to mass over volume. So if you want to solve for the mass, or in this case the weight, you just cross multiply, and this tells us that the mass is equal to the density times the volume. So that's why we're going to multiply the volume by the density. So essentially what we're going to find here is that the mass is 44, and we have pounds per cubic feet, times the volume, which we have written like this, 30 over 4 cubic feet plus 27 over 4 cubic feet. Now the units here don't matter because it's multiple choice, but I'm just showing this with the units. But you can see here when we distribute and we multiply pounds per cubic feet by cubic feet, you can see how cubic feet cancels and it gives you just pounds. So now another concept that's jumping out at me is that when we multiply by 44, 44 over 4 is going to simplify. So I'm going to have 44 times 30 over 4 plus, and we're going to have 44 times 27 over 4. But 44 over 4 is 11. So that's going to happen twice here. And of course, this is all being measured in pounds. So now what we have is we have 11 times 30, and that's going to give us 330 plus, and now we have 11 times 27. So in my head, just a little bit of mental math, I'm doing 270 plus 27, and that gives us 297. So that's where I'm getting these numbers from, and this is just going to be in pounds. So now if we work this out, I could use a calculator, but I'll just practice long addition here. So that's going to be 7, 2, carry the 1, 627 pounds. So that's how much this weighs, and approximately this is closest to choice 1. So question 22, all this given information tells us what's going on in this diagram, except this part. This is something new. The measure of angle ATV is equal to the measure of angle ABC. Now, because these corresponding angles are the same, that means that these two lines are parallel, and that tells you that triangle ATV is similar to triangle ABC. So that's just something that jumps out at me right away. And now I would just start labeling. So we have AT is 4 units. We have BC is 18 units. Then we have TB is 5 units long. And AV is 6 units. And we want to know the perimeter of quadrilateral TBCV. So there's a lot going on here, but what I recommend for questions like this is drawing the triangle separate. So we have ATV, and this is 4 and 6. And then we have the big triangle. So the big triangle is ABC. And I just label everything that we have so far. So 5 plus 4 is 9. And then this is 6 plus blank. We don't know what that is yet. And then this is 18. So if I want to find the perimeter of this thing, I need to know what is VC. So first thing I'll find here is this side length. So what we could do is we could say the left side to the right side, that's 4 over 6, is equal to the left side to the right side is 9 over x. So I like drawing the triangle separate because then when you're setting up your proportion, it's easier to be accurate. So now here I could reduce this before cross multiplying, or I could just do it now. This is 4x equals 54, and then divide both sides by 4. And that tells you x equals 4 goes into 5 once with the remainder of 1. 4 goes into 14 3 times with the remainder of 2, and 2/4 is equal to 1/2 or 0.5. So that's how I know this whole thing is 13.5. And if this is 13.5, 13.5 minus 6 is going to give us 7.5. So that's the length of this side over here. So that's 7.5 units long. Now TV, to find this, I could just set up another proportion. So let's say I just put a y here. I could say 4 over y equals, so that's the left to the bottom, equals the left to the bottom, 9 over 18. And this one, just so the numbers are nice, I'm going to simplify this and say 4 over y equals 1 over 2. And I think we can see here that y is going to equal 8. Or you just cross multiply y times 1 equals y, and 4 times 2 is 8. So this side is going to be equal to 8. So TV is 8 units long. But now the perimeter of this thing, we just have to add these 4 sides up. So now we do that. We have 8 plus 5 plus 18 plus 7.5. So now these two are going to make 13, and we have plus 18 plus 7.5. If I was doing this without a calculator, I would add those two, and that's going to make 20.5 plus 18, and I'll just put a 0.0 here. So now this is going to work out to 38.5, choice 1. Question 23 is a nice question because it has a lot of concepts layered together. So we have a circle centered at the origin, that's the point 0, 0, and it passes through point A, which is at negative 3, 4. So we want to know, what is the equation of the line tangent to the circle at point A? Well, one concept that you need is that when you draw a tangent line, the tangent line is perpendicular to the radius. So, and we're talking about the radius that meets the tangent line at that common point over here. So that this is going to be a 90-degree angle. So once again, the tangent line, and you should definitely make sure you have this because this is a really big idea. The tangent line is perpendicular to the radius at the common point, okay? Or yeah, at the point they share. All right, so this is a big, big idea. And that's what's going to help us answer this, because this is the point negative 3, 4, but because we're at the origin, the point negative 3, 4 is going to tell us the slope of this blue line. So the slope of this blue line, you can see this is the point 0, 0, and point A is at negative 3, 4. That the slope of this line, I'll just call that M1, our slope, and we should know this equation, that slope in general is y2 minus y1 over x2 minus x1. But we could do y2, we'll call this y2, 4 minus 0 over negative 3 minus 0. So the slope of the blue line is negative 4/3. And just know the negative could go on bottom, top, or in front. So that's the slope of the blue line, but we have to know what is the slope of the red line. But because they're perpendicular lines, their slopes are negative reciprocals. So we'll say the slope of this line is M2. So the slope of the perpendicular line, we're going to flip and negate this. So since it's negative, we're going to make it positive, and we flip it to 3 over 4. So now we know our line is going to have a slope of 3/4. So that's going to eliminate choice 1 and choice 3. Now the next equation that helps to know is y minus y1 equals m times x minus x1. This is the point slope form equation of a line. So what we have is this point I'm going to now name this point. I'm going to call this x1, y1. But we're going to use this slope. All right, we're writing the equation of the red line. So that's the slope we're going to use. We're going to have 3/4 times x minus x1. So we have x minus minus 3 becomes x plus 3. And then we have y minus 4 equals. So that's going to match up to choice 2. Okay, for the final question of the multiple choice, we got a lot going on here, but we have this circle. We have a quadrilateral inscribed in circle O, and we have the measure of these three angles here. We want to know, what is the measure of angle D? So for this one, these could be a little bit tricky to know, but you have to just look at this carefully and try to see something that gives here. And the thing that jumped out at me first, after looking at this for a little while, is when I looked at this angle here, angle A. You see how angle A sections off this part of the circle. So we have this part of the circle here. And then the next piece that I wanted to look at was the other remaining portion of the circle, which is this part, and that is intercepted by this inscribed angle here. So this inscribed angle intercepts this arc, and angle A intercepts this arc, which is the red and the blue make up the entire circle. But now what you have to know is, what is the relationship between the measure of the inscribed angle and the arc? Well, the arc is double. So if this is 2x degrees, then this arc here in blue, I'll color code this. This entire thing here is going to be 4x because it's double the measure of the inscribed angle. And now this one here, this angle is going to be 2 times x plus 15, which that's going to work out to 2x plus 30. So now we just have to think here, what is the measure of the full spin of a circle? That's 360. So if I go 4x plus 2x plus 30, this is going to give us the full circle, 360. So now just simplify this equation, solving for x. So we have 6x plus 30 equals 360. And now we just do minus 30. And this is going to cancel. We have 6x equals 330. Divide both sides by 6. And let's see how this simplifies. So we have x equals 6 goes into 33 5 times with a remainder of 3. And 6 goes into 30 5 times. So x is 55. So if this is 2 times x, this is going to be 110 degrees. 55 minus 10 is 45, so I have 45 degrees. And then if I do 55 plus 15, that's going to give us 70. So now just know in a quadrilateral there's 360 degrees. And that's just, if I draw any quadrilateral, I could cut it in half like this and I have 2 triangles, and 180 times 2 is 360. So that's how I know there's 360 in total. So now I would add up these 3 angles. I have 110, 70, and 45. And if we add this up, we have 5, and then we have 8 plus 4 is 12, carry the 1. We have 225, so then I just subtract that from 360, and that's going to tell me the missing angle here, the measure of angle D. And now we just have to do a little bit of work here, and you could use a calculator, but this is just faster for me instead of switching screens. If I do the long subtraction, I'm going to get 135, so choice 4.